In section 3.2, we start to talk about the spread of a distribution. There are three measurements that we're going to talk about as options for describing the spread of a distribution. There's the range, the standard deviation, and the IQR. We won't talk about the IQR until we get to section 3.3 because that's in with box plots and the 5-number summary. In this video, we're going to discuss the range and the standard deviation. So before we get to that, let's talk about what it means to describe the spread of a distribution. So when we say the spread of a distribution, we're talking about how spread out the data values are. If the data values are very spread out, that's something important to know about the distribution, as well as if the data values are really clumped together. So the question is, which of these measurements is the best description for how spread out the data is? So the first measure we're going to talk about is the range. And the range is the distance between the minimum and the maximum value. So we take the maximum value minus the minimum value, and that will give us the range of the data set. But that doesn't actually do a good job of talking about the spread of a data set, because you could have clumps within that range. Or it could be that the minimum or the maximum is an extreme outlier, making the range look really large when in fact most of the data is very close together. So the range, we say, is not resistant, which means that it's greatly affected by outliers. In this class, the range is never the best option for describing the spread. So don't pick it. You're either going to pick the standard deviation or the IQR. So let's talk about standard deviation. Before we get to the actual description of the standard deviation, we have an intermediate calculation called the variance. And the variance is the measure for how far the data is spread out from the mean. So looking at the notation here, so here is the formula for the variance. Anything with a bar above it, so this y bar, that's the mean. And the regular y is a single data value. So what this calculation is doing is it's taking each data value, it's subtracting it from the mean, meaning it's finding the distance between that data value and the mean. It's squaring it, and that's because we want all of those values to be positive. So if the distance is negative, we don't want it to counter with another distance that's positive. If we square all these distances, then all of the values are positive and we can get a better idea of the spread. So we square all the distances, add them together, and divide by n minus 1. So this adding together is an average, right? When we add them all together and divide how many there are, we're finding an average of these distances, these squared distances. A big question is, why do we divide by n minus 1? Sorry, I should say n is the size of the data set, the number of individuals. So if the data set has 25 values, why aren't we dividing by 25? Why are we dividing by 24 instead? And it's basically that a lot of really advanced statisticians got together and showed that the variance was better calculated by this one less than the actual sample size or the data set size. The standard deviation is the square root of this calculation. So they do all the same calculations, but they take the square root of it. The standard deviation is a number that is close to the average distances that the data values are from the mean. And so that's why whenever we're talking about the standard deviation as a possibility for the best measure of the spread, we pair it with the mean. So recall from the previous video, we said that we use the mean when a distribution is symmetric. And since we're using the mean when a distribution is symmetric as the best measure for the center, then we want to pair it with the standard deviation as the best measure for the spread. So because the mean is part of the calculation for a standard deviation, the mean and standard deviation always go hand in hand. So I just want to show you how to find these calculations on your calculator. What you want to do is put all the data into L1, and you're going to go to stat calc, and then you're going to use the command titled one variable statistics. And it will give you all of the main statistics that you need for any data set, one variable in that data set. So anything with a bar over it, like this is the mean. Both of these represent the standard deviation. One is for a sample and one's for the population. So depending on the context of the problem, you're going to need to decide which one of these to use. This min, Q1, median, Q3, and max, this is called the 5-number summary. And we're going to learn more about this in section 3.3. But notice that the median is part of the 5-number summary. So if you're asked to find the mean and the median for a data set, you throw the data into your calculator into L1 and go to this command. So here's the video on how to do that. So when you go to stat and edit, then you can put your data into L1. And then I'm going to quit and go to stat calc and choose the one variable stats command. It will ask me for my list, that's L1. We almost never have a frequency list. Then we'll choose calculate. And then we have all our values. So if on an exam, and I scroll down to show you that you have to scroll down to really see all of the statistics that are included in this output. But on an exam, if you're asked what is the mean and the median of this data set, you should be using your calculator and this command to find it.